All right, we're on worksheet 4B. We're using that TVM solver when applicable. And you'll find out that some of our problems that we used to do in Algebra 2, you can do on the TVM solver now if you prefer. The TVM solver, though, has to be used on any sort of annuity where you're depositing money every so often, or if you're taking money out every so often because you're paying something off.
What if
the
amount of money that you're putting in is a variable?
That's a much more complicated situation. Yeah.
Can you type in a variable on that?
On the app, I don't know. I've never tried that. I don't think so. It won't produce a function back again. I know that. And I think what happens is on your calculator, if you were to type X, all variables are stored as something in the calculator. So whatever the last thing was, it'll think it's a 4 or whatever the last kid did. Yeah. So I'm going to think the answer to that is no. But that's a great question to pose. Like, what if for the first year of my annuity, I only deposit $50 a month and then I adjust it? Basically, and for our end of it, we'd have to do a new calculation every time you adjust that number. So I wouldn't be able to long-term it with my simple calculation that I'm allowed to do in PreCalc. Right, good question. All right, so I'm going to skip around a little bit on worksheet 4B because you guys got me talking too much yesterday. Let's talk about number 2. What is the total value of an investment that is $4,000, compounded 6.2%, compounded monthly for 8 years? Okay, first of all, I call bull on this investment. Show me an investment that gives you 6.2% compounded monthly, and I will sign up for it right now. That doesn't exist. Is this an Algebra 2 question or a PreCalc question? This is an Algebra 2 question. So you are more than welcome to go ahead and do your normal Algebra 2 formula. In fact, on your no calculator test on Wednesday, there's a question where you have to set this question up. You don't actually solve anything because there's no calculator on this test, but you're setting everything up into that formula. So if you want to go all Algebra 2 with me, you would say, I have $4,000 that is growing at a rate of 6.2% written as 0.062. You're dividing it by how many times every year do we collect interest? 12. And then up in his exponent. Yep, 12 times 8. So that's the Algebra 2 version. Was everyone here yesterday? Yeah, all right, cool. Let's talk about TVM solver. If I wanted to use my TVM solver, okay, I'm going to try to go in the right order. The first thing it asks you for is N. What would I have typed in for N, the capital N, on TVM solver? That's the 12 times 8 part, right? It's how many times do you collect interest on this thing over the course of it? Gosh, I always get these orders. Is it interest next? All right, the next thing they would say is interest, which for the program, they don't want you to change it to a decimal, so we just write 6.2. And then it's present value. Okay, so this one, the present value is the $4,000. But payment, that's the weird one. You're not adding any money. So you're going to put a 0 in for payment if you choose the TVM solver method. Where's my thing? I can't extend my page. I don't know what happened. Oh, I'll try to fit this in here. Payment future value is the next thing, right? And that's actually what I'm trying to solve for. So this is the thing that I would just ignore for a moment. And eventually I'll do alpha enter and I'll solve it. And then payments per year and compoundings per year should be the same, and they're both 12. So if I already knew I was going to use TVM solver a whole bunch on my homework assignment or on my test, maybe I'd also use it here. Once you get all that data entered and you guys went and hovered in the screen part where it says future value, do that alpha enter thing. And either way, y'all should be getting the same answer, which I didn't write down. What is it? $0.18? Okay. And that answer shows up either on the TVM solver or on the Algebra 2 formula. Again, I don't think that annuity exists, but nice try. Now, on number 4. 5 years from now, how you would like to have to... I got a lot of problems with this problem, guys, okay? 5 years from now, you would like to have $10,000, cool, to pay for a trip around the world. I don't know how you're getting around the world, but I'm not sure $10,000 is going to cut it. You're going to, like, be on a boat or something. I don't know. I think you can go to Disney on $10,000 and go to Epcot. Will that work? I can't. I've been trying.
What do you mean? Are you trying to stay on Disney?
Yes, of course.
I mean, I've never stayed on Europe or something. You can
Well, we're a fancy folk, the Abruzos. We stay on property.
Apparently.
All right, Disney, if you're listening, I would love to be given a free vacation. Sponsor my channel. I'm a big hit in Europe. Euro Disney, okay? I'll go there too. All right, so $10,000, sure. All right, your investment company says that you'd be able to earn 5.5% compounded monthly. How much would you need to invest today? All right, so technically this is an Algebra 2 question because we're not adding any money to this on a monthly basis, so whatever. Besides the interest. We can use TVM Solver though. So N, where are we at? How many years? 5 years. And we're earning interest monthly. So it's collecting 60, yeah. 12 times 5, better known as 60. You can just enter it as 12 times 5. The interest rate, 5.5, sure. The present value, I don't know the present value, right? That's what they wanted me to figure out. So this is going to be the thing that we're going to solve for. I hear you guys already typing. All right, payment. Are you going to be adding money every month? So you got 0 on that. Future value, this I do know, and I want it to be $10,000. And while we're not paying anything every month, we are collecting interest every month, so 12 and 12 on that. So, how much money do I need to throw into my bank account right now? 50 cents? That'll make all the difference at 50 cents. Okay. So if you happen to have $7,500 sitting around, throw it into this magical thing that collects 5.5% interest and let it sit for 5 years, and then boom, you'll have $10,000 to go on a really nice Disney trip.
What would be a more accurate interest rate?
Well, not 5.5.
Yeah, I know.
So for a lot of the things that investments offer you, like the higher the interest rate, the more risk associated with it. Like if you're putting into something nice and safe, your interest rate's incredibly low. Definitely single low digits. Like my kid's 529 right now. They have them going to mutual funds, but like they're riskier right now because my kids are small, right? So they figure if the stock market takes a hit and everything drops, like by the time my kids actually go to college, things will have recovered. So they're putting them in riskier investments right now than they will. Once they become older, they start pulling them out and putting them into safer locations. The interest rate becomes much lower when they're older because of where they're placing them. Well, they're choosing where exactly to place them. I don't make those decisions. Someone very smart does. Okay. So they analyze the risk associated with where they're going. Yeah. What sort of, I don't know exactly what they're putting them in these days, but I could tell you they're fairly risky, but the payoff is that they've seen success over the last few years, so they've been growing pretty decent for these years.
Typically, higher the risk.
Mm-hmm. So as my kids become older, the financial advisor who's in charge of this will start slowly taking them out of those riskier investments and putting them into something very safe, very low investment rate at that point, but very safe. That did not happen to my college fund. Fun fact. Because I think my generation really got the hose. So like the housing market crashed when we're all trying to buy houses as young adults. But guess what happened when we all tried to go to college?
Great Depression.
Not the Great Depression. Thanks for that. A pretty big hit to the market. And my poor little college fund, right? Like, literally got sliced in half right before I went to college. The Great Depression. You fail, Daniel. Thanks. All right. Let's move on. Jerk. You have your first full-time job. I love this question because this is really depressing. You get to start an annuity to save for your retirement because that's what every first-time job worker wants to think about. When can I retire? So this one's really adorable. Let's find out what happens when you decide to invest $50 every month for the next 40 years. Now, first of all, do you guys plan on working for your job for 40 years? You should. That's probably your normal. I mean, not the same job necessarily, but yeah, you're gonna be working for a while. Sorry, us old people are gonna take all of your Social Security away, so you'll have none. Hey, okay, ready for this? 40 years. we are going to be placing money in every month. So we're going to have some balance change every month. 40 or, okay, there we go. 40 times 12 or 480. Okay. Interest rates. All right. 6.5%. Sure. Present value. Now we didn't make an initial deposit, so we're not starting with anything, but every month after we start working, we're going to be paying $50 into this account. The future value is what I'm going to determine, so we're going to leave that alone for a minute, and we'll solve it when we're done. And then 12 and 12. All right, so let me actually not be lazy and pull up my own calculator.
Wow.
Hey, you already found the answer. Shh. All right, so I go to apps, and I choose Finance app. And yeah, right, this is depressing. So TVM solver, and then you can either do 40 times 12 or just type a 480. It'll change it for you. I forgot the rest of this problem. Was it 6.5? And then none, and then he's paying $50 a month. Dream big, fella. Gotta change these to 12s. It'll change the bottom one once I change the top one. All right, now for future value, this is what I want it to calculate. So I'm going to command it to calculate by going alpha enter, which is solve. Huh. What does that say? 114,000?
Yeah.
I was hoping that was a decimal misplacement, but it's not. This dude, I know it said negative, but that's because they're going to pay it out to him, is going to accumulate 114,000. What's the rest of it? What's the dollars here?
$180.
95 cents. Thank you. Okay.
That's terrible.
Well, yeah, and unfortunately, there's a lot of humans out there who are like, well, that sounds great, $114,000. 40 years from now, remember, things inflate. I don't know if $114,000 sitting in your bank account is enough to live off for the rest of your life at that point.
It would look really nice for about a year or two.
Right?
Really nice.
Right. Like 1 year,
I mean,
two if you stretch it,
live really nice for a year, live comfortably,
and then die?
and then die. Go back into
Okay.
the workforce, or invest that. Take a big risk.
Yeah.
Invest
So,
all of it.
like, this is a depressing question to have answered. Like, how much do you need in this annuity to feel like, yes, I can retire comfortably? And that answer is very difficult to come up with for you guys because I have no idea what's going to be happening in your world 40 years from now. Wow. That's sad.
Wait, how much do you say you need for at least $1 million?
Yeah, so the current generation who's trying to retire has been told, like, you need $1 million to live the rest of what we think is going to be your life. Because remember, you're all living longer, too. Darn
So
technology.
We're working till we're 80.
You gotta work till you're 80. You'll probably live until you're 110. So you gotta. Oh man! But then don't forget the Earth is dying. So, oh gosh. Oh man, how depressing. Okay, so this dude, this child who just started their job is like, okay, well that's not gonna work for me. Let's dream bigger. Let's do $100 a month. Let's see if we can swing $100 investment. So your payment, let's change that to $100. They find something a little riskier. The interest rate goes up to 7, and they're going to commit to working for 45 years instead, right? So now it's 45 times 12. Let's see if this changes things. It's got to change something.
No.
I mean, it's better.
It's better, but
How much?
$379,259.47.
Okay, well it's better. We can live for another few more years. Hopefully the Earth hasn't, pooped out at that point. I don't know. Maybe one of you will discover something really amazing that saves the Earth and allows us to live on $300,000.
How old are people working? Like, how old are people when they stop working?
I don't know. We'd have to look that up. I think nowadays, if you guys think about your grandparents.
I mean, looking at all the people at Walmart, all the greeters, they look like they can be like 85.
Well, and I think that is a societal issue of people are having to work longer or go back to work. Like maybe they were an electrician as their trade for their job. They retired because there's a lot of cool benefits for many jobs when you retire, and then they end up going back to work for whatever reason. Sometimes it's just boredom, but sometimes it's I need the money. Yeah. I can think of like my My in-laws like cannot retire because they haven't hit that mark yet as far as they don't have money. I think if you guys think about your grandparents, are any of them still working?
No.
Well, that's very fortunate for them. And a lot of it has to do with what job you go into. I mean, a lot of our trade professions have wonderful benefits while you're working and then when you retire. Will that still be there in 40 years? I don't know. I hope. All right, so this one is a little more realistic, guys. I want $1 million in my account. True words have never been spoken. But I'm going to be working for 50 years. That's about right. I'm aware, I guess, that I can earn 8% interest on this annuity. I don't know where this is, but cool. What does my monthly contribution have to be? So I know that while I'm maybe not starting with a chunk of money, but I have to contribute every month, and I have to commit to this, okay? So 50 years, and then we're, what are we doing, monthly? Yeah, monthly, so 12. The interest rate, you're already typing. You're going to have the answer before I even get it written down. The interest is 8. The present value is nothing. I got no money to offer you. I just graduated college. Back off. The payment is something that we're going to be solving for, so I'll leave that alone for a minute. Future value, I want it to be $1 million. Make sure you get all those zeros in there. And then payments and compoundings per year are both 12. How much money do we have to contribute every month?
Wow, that's cheap.
Oh. Well, let's do that. What is it?
$126.08.
I think this is the best piece of advice anyone could give you for the rest of your high school career. Do that. Start right away. I didn't. And I'll never get to leave here, I think. I'm a little worried.
It's okay.
Cool beans.
Think about it this way. You can teach my kids.
Yeah. Did you live through the Great Depression? Hey, just out of curiosity, if you contribute 120, let's just say 126, times it by 50 times 12. I want to know how much money you actually put into this account, like from your pocket.
$75,600.
Okay, so think of it in terms of that. Over the course of what you're forking over, you're physically contributing 75,000 of it. You're coming out with $1 million. Man, talk about gambling. That's a sure bet. Now, this 8% thing, I'm a little like, where's this 8% you're finding? I don't really know that that's maybe. I don't know. You can lock it in. I don't think that's the way it works. So maybe. I don't know. Maybe don't take it financial advice. I'm basically like a what not to do poster child. So I can tell you a lot of things not to do. If you're looking for what to do, seek financial help. Okay. Can we start talking about the no calculator quiz now? Okay. So the purple thing that you picked up, I would like you to save that for Tuesday. So don't do it this weekend.
Because it's for work time on Tuesday.
I was really looking forward to doing this weekend. Instead, you can do other things this weekend.
If I do this weekend,
Like finishing your homework check that you're totally almost done with. Mrs. Hoffbauer, by the way, already got a homework check turned into her. And I am super jelly. Because that kid already turned in a homework check. Where's your homework checks, people? No, he doesn't. Does not. All right. This is not the worksheet I wanted. Darn it. All right. Hold on. Give me a minute.
There we go.
I want you to find worksheet 7 and 7.5. Worksheets 7 and 7.5 are perfect for getting ready for our no calculator test on Wednesday.
Wait, so is it?
Yeah.
What are those like on this no calculator?
The purple stuff. Yeah, so the purple thing, the purple worksheet you picked up looks almost exactly like style-wise like your test on Wednesday. So when I'm gone on Tuesday at that wonderful all-day meeting, I want you guys working on the purple thing. Okay? Are there any, like, anybody know they're not going to be here Tuesday? Is something going on Tuesday? Besides an all-day, you're just not here because you got some. So you work on the purple thing early. So in class on Tuesday, I want you guys focusing on that purple thing and helping each other out. I did put the answer key at the back of it. That doesn't mean they're all right. I could have pulled a classic Abruzzo and put a wrong number, wrong sign, wrong anything. So if you notice throughout the day, like, oh boy, she just really messed up number 4, just pass the word along to your PreCalc brethren that I messed up. So, no calculator. And guys, what I mean by no calculator is no calculator, not even a scientific one. Okay? There is nothing coming your way. Just your noggin. All right. So, if y'all look at worksheet 7 with me, I believe there's some questions that are circled on your packet. Yeah, I'm gonna change which ones that you guys are doing a little bit, just because I think when Mrs. Hoffbauer circled those originally, I think she meant those are the ones that she was gonna do, and then you guys are supposed to finish it. And I was like, that felt like a lot. But I don't know if that's what she intended, so I'm a little confused. So anyways, I know she circled number 2. Let's quickly look at number 2, but just FYI, I'm going to ask you guys to also do number 1. All right, so without any sort of assistance, you guys have to identify for me. This is logarithmic form. I want it in exponential form, which means I need to identify who the base is. Who is your base in number 2? 18. Very good. So he's also the base of the exponential. And then your dyslexic teacher just thinks about things flipping around as far as order that they appear in the next part of the problem. So it's 18 to the what power?
2.
To the 2, and it equals 324. Now this, and yeah, and the new, no.
Somehow I wrote down 332
Oh.
when I clearly says.
Oh, I got you. Okay. So Adam commented that it seems like a legitimate answer, like 18 to the second power is 324. Sure. I don't know that one off the top of my head, but like 8 times 8 is 64, so it does end in a 4, so I feel like we did something right. There's no other way to arrange those numbers and come up with something that seems legit, to use your young people term, Adam. Thank you. All right, so you guys are going to do number 1. Number 1 is not, it's algebraic instead of numeric, so you're just kind of trusting that you guys understand the formula. Now, my least favorite question is number 4. I don't know why, I just really hate writing in logarithmic form. My brain doesn't like it. So I have to remember to write down the abbreviation for logarithm, and then I have to identify who my base is.
9.
It's 9. So make sure your handwriting is appropriate, guys. 9 is a tiny little subscript below the level of logarithm. I got you, man. I got the same problems. Okay, so inside of the logarithm is the 1 over 81. And then the answer comes out to a -2. Now, I'm a worrywart about these because I feel like I always do them wrong. But I'm really good at going from log to exponential. So what I will do is then I will quickly flip the formula back together. And I'll be like, yes, that is totally right. I just really hate logarithm form when it comes to rewriting. I don't know why. Let's see here. What's circled on here? Anything?
No.
Oh. I feel like you can do a couple of them. I want you to do 5 and 6, please, okay? Oh. Can we do 6? Actually, let's look at 6 together.
This is where the Marty problem is. Number 5.
Mm-hmm. Guys, what's another way of saying square root?
1/2.
1/2 power. There we go. Who's being raised to the 1/2 power here?
That whole thing.
Yeah, u and v and w. So when you start expanding this logarithm, by the way, how many logarithms are we expanding into?
3.
Who's going to have that 1/2 power in front?
And you.
All of them. Yeah. So I think you guys are getting comfortable enough with these to jump straight to the fully expanded answer.
Yes.
So if you know to throw the 1/2 in front of each logarithm, that's awesome. So 1/2 log base 4 of u. How do I separate these logs, by the way? Plus sign, good. All of them have the 1/2 in front, so 1/2 log base 4 of v. Whoops. 4. Plus, I don't know why I keep changing colors. You guys are done. All right, plus 1/2 log base 4 of w. So some kids say, can I just pull the 1/2 down in front and then just leave it in parentheses? Kinda. But you should distribute it. I know. All right, could you guys please try number 5? It looks like a good time. Can you move on to the next section? Now we're condensing. Everybody likes condensing better. You're doing 5 like you were doing 5.
Oh,
like for homework. I mean, you can. Condensing, I like condensing a lot better. It's much easier to determine that you're done because you're going to have like log and then something in it. So on 11, let's look at 11. The 2 is going to be brought back up into the exponent position, but But careful on this next logarithm, guys. It's natural log divided by 2. A more appropriate way of you guys interpreting that is that it has a coefficient of 1/2. So it's like 1/2 logarithm. So the 1/2 power goes up in the exponent. I'm curious if you guys can give me the best pre-calc answer you can give me. I know it's z squared. But what's going on with the x? I know it's to the 1/2 power, but what's a pre-calc way of saying that?
It's square rooted.
Thank you. The 1/2 power, more appropriately called square root. Could you guys please do number 9 on your own? Oh, perfect. All right, this is great for your no calculator test. So, can we look at 17 real fast?
Yes.
Think. Log. Any base. Applied to a negative 81.
Yeah.
It's a thinker, isn't it? If I just keep writing question marks, does that help?
Wait, no. I'm hearing, I didn't even realize you were writing. What are we trying to say?
So, okay, so I hear some people doing this. 243 raised to what power gives me a negative 81? And then you should still be confused.
Because it's imaginary.
It's undefined. There we go. Ah, you guys can't find the answer. It doesn't exist. All right, so, yes, there is one of those on the... Okay, so, guys, yes, you can interpret it as, awesome, there's one question that I will definitely know the answer to. So, your logarithm, no matter what the base is, guys, logarithms are not defined to be applied on negative x values, or negative inputs, I should say. So, like, you can't take the log of a negative 81. You can't take the log of a negative 6. You can't take the log of a negative 2. Why? The best explanation I can give you right now, Daniel, is the shape. Yep, vertical asymptote. Yep. They are not defined in negative x land, so you won't be able to input a negative value. Very good. All right, and that goes for all logarithms. All bases. All right. Talk about number 20. This one you can do. 4 to what power? You're going to do these for me. 4 to what mystery power gives you a 1 over 64? Without a calculator, by the way. 16 would be really large. Like 4 times 4 times 4 times 4 times 4, 16 times would be huge. You got it. It's a pretty small number. Okay, I heard negative. Why is it negative? We need to flip it to a fraction. And then I'm hearing 3. Does that work? Because 4 to the 3rd power is 64. Now some of you are like, oh my goodness, I'm supposed to know that? Yeah, but I do have a chart of numbers that I will share with you on testing day, okay? That would be nice.
Like 6th grade was.
Crafty. I'm going to bust out the Cricut. Make you guys all a little number chart. I don't have a Cricut. My mother does.
But they has a massive Cricut.
That's true.
You can get that one. You fucking steal that.
All right, so please do numbers 22 and 24. I think you do. All right, let's talk about graphing logarithms real quick, guys. Can you guys actually find page 7.5? Well, that's what we got to talk about. All right, so 7.5. I want to talk about... Now, the key's on the back of 7.5, by the way, so don't be surprised when I don't post the key. It's already there. But graphing exponentials, I think you guys will be fine without a calculator. You'll just choose your favorite x values, plug them in, and you'll be fine. Now, the ones on the test for Wednesday are very basic. It'll be like 3 to the x power or 2 to the x power. There'll be no transformations whatsoever in them. So, like when I look at number 1 and 7.5, that's very much like what you're going to see on your test. But let's talk about how we graph a logarithm. So number 3 on worksheet 7.5 is a log base 3, but then it's not of x, it's of x minus 3. So this logarithm is it left 3? It's right 3. Okay. So this has been shifted right 3, which adds like a whole nother level of fun to this problem. So I'm going to promise you that on your test on Wednesday, your logarithms will not have transformations in them. So there's 3 steps to graphing this one, guys. 3 steps that you got to follow since we don't have a calculator. The first 2 steps you'll do on the test on Wednesday, and then the 3rd step where we apply the transformation at the end, you won't have to do on Wednesday. So step 1 is to make a table of the inverse's parent. So the inverse to a log base 3 would be 3 to the x power. So I don't really know what happens with a logarithm base 3, but I'm totally good at interpreting 3 to the x power. So if I make a little table for 3 to the x power, I plug in my favorite x values, which generally are -2, -1, 0, 1, and 2. And again, without a calculator, so this is something that you will have to do on the test. If you plug in a -2 up into the exponent, think about what happens here, guys. 3 to the -2 would be like a 9 that got flipped, so 1/9. 3 to the -1 is 1/3. 3 to the 0 is 1. 3 to the first is 3. 3 squared is 9. So step 2 would be to graph the inverse, because that's what I truly want. So the inverse to this function is just when you take your x and your y and you flip them around. So you don't have to rewrite the table, guys. Usually we just do this. Like we take the table and I draw a weird arrow at the swoopy part of the bottom there. So, yeah. So here we go. So it's going to be, let's see if I can, you actually have a graph, right?
Yeah.
Okay, so you guys might want to start doing this. Now, we're not graphing the final answer here, guys. We're just graphing the parent function right now. So, good luck, Abruzzo. I'm going to plot 9, 2 first. And then I'm going to pretend that 3 1's over here. And then 1 0. And then 1/3 -1. And then, yep, totally nailed it. Okay, so that's the shape of what would have been the logarithm. If this was on your test on Wednesday, this is what I would ask you to do. Graph your logarithm, watch the vertical asymptote, you'd be done. However, on your worksheet, there's a little extra bonus fun here. Everything got transformed by shifting to the right 3 units. You use pencil, you'll be fine. So all of these points that you just plotted for me need to be shifted to the right 3. So like this guy ends up at, oh boy, I'm going to fall off. Pretend that's at 12. And then this guy's going to be over here at 6. And then this guy's going to be over here at 4. This guy's going to be over here at little after 3, and pretend, because I didn't draw it right.
Yeah,
oh, man. Missed every single point. Okay. So what I'm telling you is that the step 3 here is that you're going to apply whatever apply the transformation at the end, okay, of your homework. So give me the parent, flip it around, graph the inverse logarithm, and then move it on the homework. On the test on Wednesday, you don't have to do step 3 because there's no transformation. So basically you're like, who's the parent? Flipsies it around, plot. Watch the vertical asymptote. So like this particular one, where's the vertical asymptote located now? Yeah, it's over here at 3. So it would be very brilliant of you when you're graphing on your test on Wednesday to bust out the highlighter and draw me a little highlighter line at the vertical asymptote so you don't violate it. It'll be at 0 on the test. It won't be shifted. Question? No question. All right. There's more of those evaluating expression things at the bottom. And I'll leave that for you to have fun with. Could you all go back for a moment? That's not what I wanted. Back to worksheet 7. We talk about 7 and 8. I'm going to be honest. I kind of feel like 7 and 8, like they're good practice for your test on Wednesday. I think 8's a little harder than anything we're giving you, but that's okay. So for number 7, leave the 2 out in front and let's discuss this logarithm. So you have logarithm base 8 applied to a square root of 64. Now, let's just stop right there. You got a way better name for the square root of 64.
8.
It's 8. So let's rewrite that as log base 8 of 8. So, yeah, right away Daniel said, oh, it's 1. Did you use the inverse property? Did you rewrite it? Did you think about it? What'd you do? You just know it's 1? Okay, so there's a property out there that says, like, if these match, the answer is 1. What you guys can do to kind of stay consistent with your, like, how you're approaching this test, you can rewrite it in exponential form. So, like, 8 to what power gives me an 8? 1. So this green bubble here is just a 1. So this says 2 times 1, better known as 2. So that's a very good question that you might see on your no calculator test. But let's look at number 8. This one's a little challenging in my opinion. You've got the square root of 5 as a base, and then 125. Huh. So I think this one we should go ahead and rewrite. So let's rewrite it as 5, and then normally I put a question mark. Because I kind of see the writing on the wall in this question, let's go ahead and call it to the x power. 5 to some mystery power equals 125. Oops, no, I lost something. What'd I lose?
You lost the square root.
I lost the square root, which is really what power?
1/2.
Thank you. All right, so it's x times 1/2 up here. Thank you. All right, equals 125. So this would be very easy for my brain to interpret if I could rewrite them so they're both the same base. So I'm going to leave 5 to the 1/2 x looking like that. Can you rewrite 125 so it's secretly a 5? There we go. So this would be something that we could interpret now. 1/2 x power has to be the same thing as 3. So that means x equals 6.
Oh, sorry, I was thinking powers. So
Oh, good. Yep, so these are multiplied together. So yep, we're going to multiply by 2 or divide by half and get x equals 6. So that had a little bit of a challenging twist there with this, with the already existing square root on a base. That's weird. We don't usually see that. All right, so for homework, you guys are finishing up your homework check. I want it done, done, done when you walk in on Tuesday. You can even turn them in on Tuesday. I will be very pleased to see some homework checks. I want you focusing on the purple review during class. I apologize if there's any mistakes on there, but the key is on the back. Test is Wednesday.